grade 12s and physical science fanatics. Let's continue with our journey of electrolytic cells. I've got 2 or 3 questions that I want us to go through them. The problem solving in electrolytic cells. Problem solving in electrolytic cells. Electrolytic cells. Now the first question is this one. In front of us they say a simplified diagram below represent an electrochemical cell used for the electrolysis of a concentrated sodium chloride. X and Y are carbon electrodes. We know in the cell we are using the inert electrode, and what we know is that the types of electrochemical cells that we are confined to, it's a galvanic cell and the electrolytic cell. So this is an electrolytic cell. So the first question they say, define the term electrolysis. We know that, and electrolysis, it's by definition from the examination guideline, it's a process whereby electrical energy is converted to chemical energy. So that is the definition. A process whereby a chemical reaction is as a result of electrical injection. Now the second question, 9.2, they say to us, chlorine gas, which is Cl2, is released at the electrode X. Remember in our notes when we were dealing with this section, we said chlorine gas is always released at the anode. So and the hydrogen gas is released at the cathode. So when that way chlorine gas is released, obviously it's the anode. According to this one, let's listen to questions. They say write down the letter X or Y of the electrode where oxidation takes place. So they are saying chlorine is released at X. Thus, from our notes that chlorine is released at the anode, therefore oxidation takes place at the anode, then will be letter X. In this case, our answer will be X. Fine. They're saying to us again in 9.22, 9.2.2, they're saying write down the half reaction that takes place at electrode Y. Remember, oxidation is taking place at the anode. That's where chlorine is formed. Therefore, the other electrode will be where reduction is taking place. We know that that's where hydrogen will be formed from the reduction of water. Then we go to the electrode potential table. You still remember it. We'll have the reaction whereby hydrogen is formed. Obviously it's found right here. We copy that reaction. It will say we copy the forward reaction, which is the reduction. 2 water molecules plus 2 moles of electrons will form hydrogen gas, then plus 2 OH minus. That's the case. Remember, the OH minus is telling us that the solution is basic, but hopefully the question might come. Let's continue. 9.2.3, they say to us, write down the direction in which electrons flows in the external circuit. We know generally the electrons flows from anode to cathode, meaning that now if we know that electrode X is where oxidation is taking place, is the anode, therefore Y is the cathode, therefore obviously electron will be flowing now from X to Y. So you tell the examiner that according to my knowledge, then now this will be from X to Y. The next question, which is 9.2.4, they say to us, write down the balance equation for the net overall cell reaction that takes place in the cell. Remember, the net overall reaction will be formed from two half reactions, which are, it's a reduction half reaction, which we already have. We can write it down, rewrite it. The one in 9.2.2 is the one that is taking place at the cathode. Then this will be the reaction, hydrogen gas, and then plus 2OH minus. That's the one that takes place at the cathode. And at the anode, that's where chlorine is formed. We know from the electrode potential table, chlorine is one of the strongest oxidizing agents. Then we'll be somewhere there. We'll be now copying to say, according to the formula sheet, chlorine gas will receive 2 electrons. Oh, sorry. Chlorine gas will be formed. Then we write the reverse reaction. So that's the oxidation. 2 chlorine ions will be attracted to the positive electrode, the cathode, forming chlorine gas in this case, and then plus 2 electrons. Now the two reactions, we balance them using electrons. Fortunately, electrons here on the left and on the right are equal. Cancel them out and write what is remaining. Therefore, on the left hand side, I'm remaining with water on the top one. The bottom one, I've got 2Cl minus. Then the top one, I'm remaining with the hydrogen gas plus 2OH minus. Bottom one, I've got chlorine gas. This is the balance equation that they are in need of. Normally you get 3 marks out of this one. I think that's the case with the question as well. And last 2 questions, 9.3, they say to us, how will the pH of the electrolyte change during the reaction? We said because we are forming OH in the process, obviously OH is a base. We expect the pH, they say, choose from increase, decrease, or remains the same. Therefore, the pH of a base will be higher, then will be increasing. In this case, of the electrolyte, the pH increase. Write the word increase, increases. The last one, for 1 mark again, they say give reason for your answer. Already we say because of the OH that is formed in this reaction, the OH, which is a base, therefore you can just tell the examiner that OH ions are formed. OH ions are formed. That will be, or the solution is basic solution, or alkaline solution. I think that's the end of this question. It was 11 marks. Let's pause. We'll find the next one now. Thank you.